Welcome to the Distributed Cloud Computing video lecture series. Today we will be exploring one of the significant advancements in modern computing, distributed systems. The title of our presentation is Motivation for Using Distributed Systems, which sets the stage for understanding why these systems are not just a choice but a necessity in today's interconnected world. Distributed systems power everything for cloud computing to online banking, and they makes the impossible process possible. So now, what are distributed systems? At their core, they are about collaborating independent computers working together as a unified whole. So think of it like a symphony orchestra. Every musicians play their part, but together they create something much greater. Distributed systems share tasks, data, and resources to solve problems that a single computer simply cannot handle. For example, consider a large e-commerce platform. There, thousands of servers worldwide will be coordinating to ensure seamless shopping experience. They are independent, but their collaboration is what makes the system work smoothly. The key features we will focus on are independent, collaboration, and distribution of tasks, which form the backbone of such systems. So in the motivation of using distributed system, the first motivation is inherently distributed computation. So certain tasks are inherently distributed by nature. So these are problems that cannot be efficiently solved by a single computer due to physical or logical constraints. So take banking sector for instance. Imagine transferring money from an account in New York to one in London. A single computer in either location cannot manage this efficiently because it will be requiring communication across long distance. Another example is your online voting system. So here votes are collected from participants across a country or even globally. Such problems demand systems that operate in multiple locations simultaneously. So distributed systems excel in handling such scenarios, making them indispensable for naturally distributed computations. The second motivation is resource sharing. One of the most practical motivations for distributed system is resource sharing. Imagine an organization with offices in multiple cities. Instead of replicating all resources like database, printers, or specialized softwares in each office, the distributed system allows efficient sharing of these resources across location. For example, consider a distributed system like IBM DB2. So instead of duplicating a massive database across all servers, the data is partitioned and stored efficiently, ensuring performance and reliability. Similarly, distributed systems allow remote access to expensive peripherals like the 3D printers, saving cost and avoiding duplication. So access to remote data and resources. Sometimes resources are so vast or sensitive that they must remain centralized but still accessible remotely. So think of large data sets like satellite images used for weather prediction. These files are too big to replicate everywhere. Instead, distributed systems enable remote access, ensuring that teams worldwide can analyze the data without needing local copies. A practical examination is a payroll system. A company's branch office access centralized employees' data for payroll processing. Similarly, distributed systems allow researchers to tap into the immense power of supercomputers, running simulations or calculations from their local machines. Advances in communication technologies have made this seamless. Enhanced reliability. Distributed systems are designed for reliability. By replicating critical components, these systems ensure that even if a part fails, the whole system continues to operate. For instance, in cloud storage solutions, your data is replicated across multiple servers. If one server goes down, another instantly takes over. This is called fault tolerance, and it's what makes service like Google Drive and Dropbox so reliable. The key aspects of reliability includes availability, ensuring services are always accessible, integrity, ensuring data correctness despite simultaneous access, and fault tolerance, allowing recovery from failures without service interpretation. Increased performance or cost ratio. Distributed systems aren't just reliable, they are also cost efficient. Instead of relying on a single expensive supercomputer, tasks are distributed across multiple affordable machines. This concept is called parallel processing, where tasks are distributed and executed simultaneously by multiple computers. For example, a network of workstations connects standard computers to perform high-speed computations, offering an excellent performance to cost ratio. This approach is widely used in industries like animation rendering, where thousands of machines work together to produce stunning visuals. Scalability. Scalability is a hallmark of distributed systems. These systems can grow seamlessly as demand increases. Unlike traditional systems where adding more users or tasks creates bottlenecks, distributed system allows horizontal scaling, adding more machines to the network without performance degradation. Consider Google platforms like Amazon Web Service or Google Cloud. They scale effortlessly, handling everything for a small startup's websites to the data needs of Fortune 500 companies. This scalability ensures that distributed systems can evolve with changing requirements. Modularity and expandability. So finally, distributed systems excel in modularity and expandability. They are built from independent components that can be added or replaced without disturbing the systems. Imagine adding new servers to a cloud system. Middleware software acts as a bridge, ensuring the new components integrate seamlessly. This modularity allows distributed systems to support heterogeneous environments where different types of processors and softwares coexist, working together harmoniously. This flexibility is what makes distributed systems the backbone of modern adaptable computing infrastructures. To summarize, distributed systems address some of the most complex challenges in computing. They excel in solving naturally distributed problems, enabling resource sharing, providing access to remote resources, and ensuring reliability through fault tolerance. They boost performance at a lower cost, scale seamlessly, and offer modularity for incremental growth. These systems power modern innovations like cloud computing, online gaming, and global financial systems. They are not just a technological choice but a necessity for the demand of today's interconnected world. Thank you.